Hi everyone, this is going to be a lesson about the periodic table, elements, some other basic things like diatomic molecules, and the atom. It's probably a good idea to maybe print out a copy of a periodic table and label it, or you can sketch one in your notes. If you notice, the columns are labeled different things. Columns go up and down on a periodic table. Labeled left to right are rows. Columns go up and down. Another name for columns are groups or families. Again, columns go up and down on the periodic table. So if you notice, this can be called column 1, family 1, or group 1. It cannot be called row 1. Group 1 is known as the alkali metals. Group 2, the alkaline earth metals. And as we keep going across, notice every group has been numbered. 1, 2, 3, 4, 5, and so on going across. If you look over on the right-hand side, there's some more names. Group 7, or also known as 17, are called the halogens. Group 8, also known as 18, are the noble gases. So hopefully you're noticing there's two different ways to number the groups. There's the consecutive 1, 2, 3, 4, 5, 6, 7, all the way to 18. And then there's another system, 1A, 2A, skip over the transitional metals, 3A, 4A, 5A, 6A, 7A, 8A. You should know both ways. In the middle, as I just said a second ago, are the transitional metals, seen in this kind of darker blue. On the bottom are the lanthanides and the actinides. These two rows actually get inserted right where you see the star and kind of like the cross. So it's like if you cut the periodic table there, push it over, those two rows actually would be inserted there. We can't insert them because the periodic table then would be extremely long. You wouldn't be able to fit on a slide or a piece of paper, so we put them down below. Next, if you notice, there's a staircase. See that staircase drawn in? That staircase has a couple of good important things you need to know. The staircase divides the periodic table from this upper staircase part, which are all nonmetals, to the lower staircase part, all seen here, which are metals. So below the staircase are metals. Above the staircase are nonmetals. The elements that are straddling, touching the staircase, are known as the semi-metals or the metalloids. If you see here, I've highlighted all the metals in gray, the nonmetals in yellow, and anything that's a metalloid is highlighted in blue. You should color coordinate your periodic table to look like this. There is one additional thing I want to point out, and if you notice right here, this is hydrogen. It is yellow because it's a gas. So why is it sitting over by the metals? Well, a gas is not a metal. A gas is a nonmetal. So it is a nonmetal. It just has a lot of properties like the other column 1 metals. Obviously, being a metal is not its property, but it has other properties that we'll talk about. So it belongs on the left-hand side. Most elements are actually naturally found on our planet, but they don't exist by themselves. They tend to kind of bond with other elements, and they make up mixtures as well. So they like to combine and react with other things. There's only a few elements that you can really find by themselves unreacted. You know, gold, for example, doesn't like to react with many different things. So you can really find a lot of pure gold. That's kind of why it's expensive. There are 7 molecules, or I should actually say there's 7 elements on the periodic table, and only 7 of them, that never like to be by themselves. These 100% all of the time will bond with another one of themselves rather than be alone. These 7 elements are hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. And they kind of make up a funny word, Hunkelbrief, good way to remember them. So as you see here, here's a container filled with oxygen gas. Here's one of nitrogen. Oxygen and nitrogen are diatomic molecules, meaning if any oxygen atom is left alone, it will automatically pair up with another one of itself, and it'll actually bond. Same thing with a nitrogen. If a nitrogen atom is alone, it will automatically find another nitrogen and pair up if there's nothing else around. These are the only 7 that cannot be alone. They're kind of like loners. But notice argon. Argon is not one of the 7. So it can be an atom all by itself. Notice it's just an atom of gas shooting around. It does not need to combine with another one of itself. It is not diatomic. Now we're moving on to atomic theory. Atomic theory talks all about how the atom has evolved over the years. Democritus was one of the first philosophers to talk about the atom in 400 BC. He called the atom atomos. Then in the early 1800s, Dalton came along. He was another scientist seen here. Very distinguished. Apparently putting your hand inside your coat pocket was very popular, thanks to Napoleon, I'm guessing. Or maybe thanks to Dalton, actually. Dalton said these things listed here. He said atoms are the smallest particle and they're indivisible. Atoms of one element are alike. So if you had copper and you found atoms of copper anywhere, that they're going to be the same if they're copper. And atoms of different elements are different. So zinc is going to look different. Then he went on to say atoms of different elements combine in simple whole number ratios. So like hydrogen and oxygen can combine. And we know this because we see such molecules as H2O, whole number ratios, not in half number ratios, H2O. And then the last thing, reactions occur when atoms rearrange, but they are never changed into another atom. So copper can bond with zinc or some other element like bromine, but the atom itself can't just change. You can rearrange and form a new bond with somebody, so copper can now join with chlorine, but copper can't just poof, turn into something else on its own. Let's take a trip back to elementary school and talk about the atom itself. The nucleus is extremely small, found in the center, and the electrons kind of hover around in this electron cloud. This is what we've come to accept as our current model of the atom. Back in the day, Dalton did not have this model. He didn't say anything about the nucleus or about the electrons. So it is really important to know that in the beginning, these what we call subatomic particles, sub meaning within, smaller parts. So the nucleus and the electrons and the protons and the neutrons, these are all subatomic particles. He had no clue about these particles yet. Slowly as the years went by, different scientists were able to discover all the different parts of the atom, such as the electron, the proton, the neutron. If you notice here, J.J. Thompson discovered a negative part of the atom. He didn't call it anything, he just knew that there was a negative part. We later came to call it the electron. He used an experiment called the cathode ray tube. I'm going to demonstrate for this to you in class. Next came another scientist called William Thompson. And he had a model that looked like this picture seen here. They call it the plum pudding model because plum pudding is pudding with little plums inside of it. So he thought the atom looked like pudding, which is positive charge, with little negative electron plums. So he basically brought about the idea of positive charge, right? Positive charge we came to know as being a proton. So he was able to kind of bring along the next part of the atom. Then came Ernest Rutherford in the 1900s, and he was able to discover the nucleus. He said that most of the time when you can shoot particles through an atom, a lot of them went through, but occasionally some of them bounced back. And so from this experiment, he was able to conclude that there must be something in the middle of the atoms, densely packed, that caused some of his particles to shoot back at him. So he concluded that there is a nucleus, and he even concluded that the nucleus was positively charged, made up of protons. Take a look at the slide and read the rest. Here's a great picture of his experiment. He shot alpha particles into gold foil, and he noticed most went through, some deflected back. He knew gold foil was made up of atoms, right? Matter's made up of atoms, and most of the atom is empty space, but occasionally, when particles bounced back, he was able to discover that there must be something inside the atom, and thus came the nucleus. Later on, the neutron was discovered by James Chadwick. And here's some information of all the subatomic particles. Again, electrons, protons, and neutrons are subatomic. Here are the masses, which no, you don't have to memorize, but it kind of gives you an idea of who's the heaviest, right, versus who's the lightest. If you notice, the proton and the neutron weigh about the same. Here's their charge. Electrons are negative, protons positive, neutrons no charge. And here are some symbols. And this is not supposed to say no, this is supposed to say N with a 0, like that, meaning no charge.